Hello everyone, I'm Dr. Regina Anandi, Assistant Professor, Department of Artificial Intelligence and Data Science. So today we are talking about a MongoDB schemas and models. Mongo sits on top of MongoDB and gives us a structure through schemas and controls through the models. So the goal of this session is simple. Define how data should look using schemas, interact with data reliability using models. Before we move forward, let's quickly ground ourselves in the basics. MongoDB stores data in a flexible JSON-like format. That means unlike traditional SQL databases, we don't have a rigid tables. We store documents and those documents can vary in structure. So now that the flexibility sounds great, but it comes with a problem, lack of control. That's where Mongoose comes in. Mongoose gives us schema-based modeling. In simple terms, it allows us to define structure on top of the MongoDB. And finally, models. Models are what we actually use in our code. They act as an interface between our application and the database connections. So remember this, MongoDB stores data, Mongoose defines structure, models interact with the data. So here's the real issue, and don't underestimate this. So if you don't enforce a schema, your data becomes inconsistent. One document might store age as a number, another as a string, and another might not even have it. That's chaos, and chaos in data means bugs in your application. So developers need strict rules. Without rules, every part of your system has to constantly check and recheck data. That slows everything down and introduces errors. So what's the fix? Structured schemas and clearly defined models. So these are the solution for this. So instead of trusting every input, we enforce rules at the database level. That way, bad data never gets stored. So this is where people get confused. So pay attention to this clearly. A schema is just a blueprint. It defines the structure of your data, what fields exist, what type they are, and what rules they apply. But a schema does not interact with the databases. A model, on the other hand, is actual tool you use. Think of it like this: schema, designing only for designing a building like structure; model, the building you actually use. So the model wraps the MongoDB Connect collections and allows you to create data, read, update, delete. So if you remember nothing else, schema defines, model does. Now let's make this concrete. Here's a simple user schema. We define fields like name as a string, age as a number, email as a string, and then created as date. This is where structure starts taking shape. Each field has a defined type, which means you can't accidentally store text in age. You can't store numbers in email, and this schema maps directly to MongoDB documents. So every user documents will follow this format. No surprises, no inconsistency. This is where things get serious. Validation rule. We don't just define fields, we enforce rule. Take this example. Email must be a string. It is required. It must be unique. What does this achieve? First, it prevents invalid data. If someone tries to save a user without an email, it fails immediately. Second, it maintains consistency. Every document follows the same structure. And the third one is underrated. It simplifies your application logic. Instead of writing validation everywhere in your code, you centralize it in a schema. So take this away. Takeaway is actually a validation is not optional. It's what keeps your database clean and your application predictable. Now we actually define a schema. This is where we stop guessing and start enforcing structure. Look at this example here. What's happening here? What we defining: field names, data types, and this is not optional. If you skip this, you lose control over your data. And understand this clearly. A schema doesn't store data. It only defines what valid data looks alike. Schema alone is useless and unless you convert it to a model. This is where most beginners mess up. So they stop at schema. Here's how you can create a model. Now the student is a powerful. It connects your schema to MongoDB connection. So through this model, you can insert data, query data, update data, and delete data. So no model, no database interaction. As simple as that. Now let's actually use this model. If you can't insert data, everything we discussed is pointless. So look at this example here. What happens here? Before saving, Mongoose checks the schema, validates the data. If something is wrong, it throws an error. So validation is not the theory. It actively protects your databases. So here we are going to consider this as a real-time example. University management system. So this contains with student courses and enrollment. Without schema, data becomes inconsistent. Missing emails, duplicate IDs, invalid record, the whole system breaks. With Mongoose schema, acquired fields are enforced, data types are controlled, relationship states valid. So the key idea, schema ensures clean, consistent and reliable data. Without them, the system becomes unpredictable. Let's wrap this up clearly, no confusion. So let's see. MongoDB stores flexible data. That flexibility creates risk. Mongoose adds structures using schemas. Models allows us to interact with the data. And here comes the core flow. Schema, model, CRUD operations, and last is validated data. And the key takeaway, if you don't enforce structure, your application will eventually fail. Not immediately, but definitely. Good developers don't just store data, they control it. And here's some small quiz that we have learned right now. So you can answer this by saying, look at this. And thank you for listening. Thank you.